For this and the upcoming demos, we're going to use the posters endpoints of our API. As explained in the beginning of the course, this generates randomized sets of data which are larger than what we currently get when getting a list of movies. By working with larger sets of data, the improvements working with streams offer will become more apparent. This is a new module, so we're working on another implementation of the II integration service contract, stream service. Let's add a new method, getPosterWithStream. Just as before, we create a new HTTP request message. Let's import the system.net.http namespace. The URI of the resource is API, movies, a movie ID, posters, and a random GUID, as posters are generated on the fly for the demo. We add an accept header, application JSON, and then we need to send this request. To do that, we need an HTTP client instance. So, just as before, we add a static field, HTTP client, and we set the defaults in the stream service constructor. Now we can use this to send the request. Once we have the response, we can read out the content. But instead of calling read as string async on it, we call read as stream async. Behind the scenes, this uses a stream instead of an in-between string. But before we do that, we must of course ensure that the response was successful. So we add a response.ensure success status code statement. Then we need to start reading from that stream. For that, we use a stream reader. The stream reader class is defined in system.io, so let's add a using statement by pressing enter. There we go. So we instantiate a new stream reader passing through the stream reader will read from. We surround this with a using statement, so the stream reader is nicely disposed of when it's no longer needed. And then we can use JSON.NET to deserialize this into a poster object. JSON.NET supports reading from streams out of the box by using a JSON text reader to wrap the stream reader. That's defined in the newtonsoft.json namespace, so let's add a using statement by pressing enter. It's again surrounded with a using statement, so it's disposed of when it's no longer needed. The last part is deserializing from the JSON text reader into a poster object. So for that we need a new JSON serializer, and we call deserialize on that, passing through the type to deserialize to, poster. Poster is defined in the movies.client.models namespace. By writing code like this, we avoid the in-between in-memory string, as we learn on the slides. And that's it, save for one thing. In the previous demos, we never disposed of the request and response messages. When you dispose such a message, all it does is call dispose on the content. So, for string content, byte content and so on, that's not necessary. It doesn't hurt, but it's unnecessary code. When we work with read as stream async, we're working with a stream content object, and streams do need to be disposed of. So, in these cases, it's best to wrap them in a using statement, so it is disposed of. Let's do that. There we go. There's a lot more information on what to dispose of when and what effects it can have in the module on using HTTP Client Factory later on in the course. Let's put a breakpoint right after we deserialize to a poster object. Let's make sure we call getPosterWithStream from the run action. And let's open the program class so we can ensure that this time this stream service is used instead of the partial update service from the previous module. Alright, let's give this a try. Alright, we hit our breakpoint. Let's have a look at the poster. And there we go, we've got our poster object. So this works, but is this really faster? Well, we're going to have to test that. But before we do so, there's another improvement we can make. We're back at the diagram from the previous slide. We already improved one part. We're using a stream to get rid of the in-between string when deserializing. So that's good. But as we know, the content comes streaming in over the network, yet we only read out the content when it has fully arrived. That's because that async operation is only considered complete when that has happened. We can improve on that as well by considering the operation complete when the response headers have arrived and not the full content. By doing so, we're working on the underlying stream of content directly, which means less memory has to be used as the content doesn't have to be fully kept in memory. Moreover, it can also improve performance as we can start working with the data faster. To allow for this, we have to manipulate the HTTP completion mode set when sending a request. Let's do that in the next demo. In this demo, we're going to create a stream over the data that's transferred over the wire. First, let's copy the method from the previous demo and give it a new name: getPosterWithStream and completion mode. Let's have a look at the sendAsync overloads. The second overload allows us to pass through a completion option, and that can be used to specify when an async operation is considered complete, when all of the response is read or when just the headers are read. The default is that the operation should be considered complete when the content is read. But we don't want the default option. We want to start working on the response content as soon as possible, i.e. while it's still coming in. To do that, we set the completion mode to response headers read. And that's it. Let's make sure we call this method from the run action. Let's put a breakpoint after the response has been deserialized into a poster object, and let's give this a try. We hit our breakpoint, and we've still got our poster object. So this seems to work. So far, so good. But let's have a look at that code again. On the top, you can see the code from the getPosterWithStream method. On the bottom, you can see the code from our new method. That's a copy of the exact same code to read from a stream, and it's quite a bit of code to write. We're going to use this again and again throughout the course, so why not make it into an extension method to improve reuse and avoid code duplication? Let's do that in the next demo. In this demo, we'll create an extension method to read from a stream to improve reuse. Let's start by adding a new class, StreamExtensions. We'll name it StreamExtensions. As it will contain extension methods, we make the class static. Let me put our stream service next to this new class. We're going to write an extension method to read from the stream. So we're going to replace this part of the code with one extension method. Let's name the method read and deserialize from JSON. We make it generically typed as we want to be able to pass through the type of the object we want to deserialize into. It's an extension method on a stream, so that's the parameter we add with the this keyword to signify it's an extension method. First of all, we add a few checks to ensure we can continue. We check if the stream isn't null, and we check if we can actually read from the stream. After that, we use a stream reader to read from the stream and the JSON text reader combined with the JSON serializer to deserialize into an object of type T, and that's the object we return. In other words, that's the exact same code from the method we wrote in our stream service, save for this time it being generically typed. And with this, we can make our code in the stream service much shorter. So let's save this, and let's open the stream service. Let's start in our getPosterWithStream method. We now have a new extension method on stream, read and deserialize from JSON. So we call that passing through poster as the type we want to deserialize into. And with that we can get rid of all this code. So let's comment it out. And we can do the same in the other method. And there we go, much cleaner. We'll work more with extension methods later on, but first we have to test something. By working with streams, we should have optimized performance. Let's test that in the next demo. To test the improvements streams offer, we'll need one additional method that gets a poster without a stream, as we want to compare our new methods to that one. That actually follows the same logic we learned about in our CRUD service, so let me paste that in. And now let's add our test methods. We'll start with a test for the getPostersWithoutStream method. We name this method test_getPosterWithoutStream. What we want to do is execute this request numerous times, after which we can calculate the average time it took for one request. And then we can compare that to what the other methods result in. So we create a new stopwatch to allow timing this. The stopwatch is defined in system.diagnostics. So let's add a using statement by pressing enter. Then we execute the request 200 times. After that we stop the stopwatch and we write out the results to the console. One more thing we have to add is a warm-up request. When the first request to an API comes in, the API might not be fully set up and running yet. By executing the request once, we ensure that the first run doesn't interfere with our test results. Alright, that's our first test method. Let me paste in the other two. The test_getPosterWithStream method is exactly the same as test_getPosterWithoutStream, but instead of calling getPosterWithoutStream, we call getPosterWithStream. Same goes for the test_getPosterWithStream and completion mode method, where we call getPosterWithStream and completion mode. Let's make sure we execute these stream methods. For that, we scroll up to the run action, and we call our three methods. That's it as far as code is concerned. One more tip, let's have a look at the startup projects at solution level. We want to make sure that we start up the API without debugging to ensure that the debugger at API level does not interfere with our results. Alright, let's give this a try. And there we go. Working with streams and completion mode is faster than working with streams, which is faster than working without a stream. But note that these results may vary. In fact, I tested this on a different machine and I saw a slight decline in performance. We'll get to why that might be the case and why that's not necessarily a bad thing later on in the module. So far for streaming when getting data. What about posting data as a stream? We can do that as well. When we send data to an API, say a poster, more or less the same happens as when we get back a response, but just the other way around. Create a poster object, serialize it to a JSON string, which is an in-memory string, and send the whole content at once. As you can guess, instead of serializing to a JSON string, we can use a stream to skip that step, which again avoids using the in-memory string. And we can also use a stream to send content over the wire instead of sending it all at once by using stream content instead of string content. Let's see how that works in a demo.